Okay, so in this example, we've been asked to solve graphically x minus 2y equal 4 and x plus 2y equal negative 2. So this is a general way of representing those lines. And there is no added value in writing the line into a y equal mx plus c, because we know we only need 2 points in order to draw the line. So if we find those 2 points by replacing x with 0 and y with 0 for the first line, we get negative 2y equal 4, and then you solve that equation by dividing by negative 2 on both sides, and you get y equal negative 2. Always get the habit of writing your points with open bracket, x coordinate, the y coordinate, close bracket. So that's 1 point. We need to find the second point. This time y equals 0, even easier, because you get x minus 2 times 0, which is 0, equal 4, then x equal 4. So 4, 0 is my second point. We do exactly the same for the second line. Find 2 points. 0, negative 1 for the first one. And for the second one is going to be negative 2, 0. Because just replace y with 0. Yeah, so nothing too complicated just now. I just found 2 points from each. Now I'm going to draw those lines. So remember, to draw your line, you start with x and y coordinate, your axis. Yeah. So once you've got your axis, you're going to plot those points. So plot them in the right order. That means we're going to plot for the first line. So we had 0, negative 2, and 4, 0. So just plot the two. So the first one, 0, negative 2. So remember, we're looking for points that are y-intercept and x-intercept. And the other one should be on the x-axis, 4 and 0. First 2 points, you draw your first line through it. Now you hope that you've drawn the line long enough. When you draw the next line, they're going to meet somewhere, right? So the next one, we said 0, negative 1, so y-intercept, and then negative 2 and 0. And then you draw through those two. Yeah, I've put 2 different colors so that it gives you an idea to better. But have you noticed I didn't plot my 4 points and trying to figure out, oh, which line is which? Do the first 2, draw your line, do the second 2. It's so easy to mix up 2 lines that are not the correct ones, okay? Or 2 points that are not belonging to the same lines. So now we've got our intersection. You can see it's at x equal 1 and y equal, it's between negative 1 and negative 2. You can say minus 1.5, or if you write it as a fraction, minus 3/2, or mixed fraction, minus 1 and a fraction half. Okay, so solution 1 minus 1.5. So that was the problem we were asked. Draw 2 lines, find the intersection between them two, and that's your solution. Okay, so you notice that it took a while because you've got to draw graphs, etc. So can we quickly check that the points belongs to both lines? Yeah, so you can say, first one, I've got 1 for x and minus 1.5 for y, minus 4, that is 0. Whereas on the second one, you can quickly check that your solution work. 1 plus 2 times negative 1.5 plus 2, that is 0, 2. So that means I'm fulfilling those 2 lines and the points belong to both. Now, key points for quick method, like what we said, find 2 points, easy to find, x equals 0 and y equals 0. plot the two coordinates. This is just a summary of what we've just gone through. Join them up, extend the line to make sure that they cross each other, read off the solution where the lines meet, and check that it satisfies both equations. Yeah, quite straightforward, not the hardest. So as a quick exercise, what we could do, we can pick one of them and we'll do them together, and then that means you can do the other ones. So let's pick E, right? So I've got two lines, y equal 5 minus x and y equal 3x plus 1. So let me draw this. So first of all, x and y coordinate. The first line we're going to do is y equal 5 minus x. So this one, they've given it to me as an mx plus c. So my points are going to be 0 for x, that means 5 for y. And the other one, if y equals 0, I get x equal 5. Yeah? Can you see that? To get a 0 here, I need to take away 5 from 5, for example. Or solve it by bringing the x on the other side, x equal 5, or putting the 5 on the other side. So these 2 points are my first two. So 0, 5, so I'm going 0, 5 for my y-intercept, and 5 for x, and 0 for y. Yeah? So I'm going to draw that line. Unfortunately, I don't have a ruler really, but I'm going to try and do it.
No pressure.
I know. Using my pad. So it would go through these. Oops, you can see that not being straight. Now I'm going to do the other one in a different color. Let's try and do it in blue, for example. The other line was y equal 3x plus 1. We're going to adopt the same process. So this time I'm expecting the slope going upwards. So first point, 0 and 1. So that's going to be my y-intercept. And if y equals 0, sorry, that's my second point. If when y equals 0, I've got to solve 0 equals 3x plus 1, for example. Yeah? So take away 1 on each side. That means 3x equal minus 1, or x equal minus 1 over 3. So this is not going to be an easy one to do. But... So minus 1 over 3 and 0. So there is minus 1. So I need to divide that by 3. So ideally, you can see how this is not going to be easy. So to solve this using a graph, it's probably better. So basically, this is where the point is going to be. So if I had a ruler, I would have done it much neater. But that's my intersection point here. So solving this gave me the answer of x equal 1 and y equal 4. Now we can quickly check that this point here, 1, 4, belongs to both lines. So 4 for y, 5 minus 1 is 4. So I can check that is working okay. And for the next one, 3 times 1 plus 1 is 4. So I've solved this simultaneous equation graphically, and I've given the answer, and I've checked it, and it works okay. If this is the question that someone asked me during an exam, I come out and they ask me, how did you get on? I have a 99.9% confidence level that I got this one okay. It's just through the check, okay? So you've got quite a few to try, and I'll send you the package as well. So if you want, you can use that, or you can print it off, or you can use your own jotter if you've got a jotter with squares, and eventually you'll get the hack of it. It's just pure, it's to get used to drawing lines basically. Okay, so it's not too complicated. So this is how you solve simultaneous equation graphically. Now we're going to, have you noticed it's quite tedious? You need a paper, you need, so there is another solution where you can solve simultaneous equation by what we call elimination. So let's see this technique, because it's easier, I would say, because drawing lines sometimes, and it's much more straightforward. So let's say, instead of going to draw those two lines, we've been asked to solve the simultaneous equations x plus 2y equal 14 and x plus y equal 9 by elimination. So there's a technique called, we need to pick which of the first variable we want to find first, or is there a quick way to see? Step one, first thing you do is you label the equations. Okay, so you've got the first equation, x plus 2y equal 14, and the second equation, x plus y equal 9. So one we've called the A, the other one we've called the B. So some teachers you will see sometimes instead of A and B, they call them 1 and 2, but they put the 1 into inside a bubble or something. So they call that equation 1, sometimes you see them, and this is equation 2. Some other teachers use AB. It's up to you. Some use small a, small b. It's probably better to use capitals, because sometimes you're asked to solve equation with a and b's in it. So step 2, decide what you want to eliminate. So here, I've decided I'm going to try to eliminate x. If I subtract b from a, like I do a minus b, yeah, you can see that x minus x will disappear. 2y minus y will become y, and 14 minus 9 is 5. So we've got our y. So you just
decide which.
So here, because I'm doing by elimination, because the x, the factor in front of x is 1, the invisible 1, and the factor in front of the one below is 1, I know that if I do 1 minus 1, those two will disappear.
You focus on the y's.
And we're fortunate here is you've got 2y, take away y will just give us 1y. Okay, so you take them away. So a minus b will give me x minus x, 0, 2y minus y, y, 14 minus 9, 5. So we've got our first point. Remember when we were drawing this, it took us 2 points from each line, and then drawing the two lines here, we managed to get the first y straight away, the first of the two, by just doing a simple elimination. By just taking away one from the other, we managed to get y. So step 1, step 2. Step 3 now comes because I want to find x. To find x, you just sub into one of the equations to get the other variables. So remember we had two of them, x plus 2y equal 14 or x plus y equal 9. Now that I've got y equal 5, I need to use any of those two. Remember the two lines, they cross each other, so you can pick any of the two. Here, I'm going to pick the second one because by replacing y by 5, it's just x plus 5 equal 9. What do I need to add to 5 to get 9?
4.
4. So it's easy to solve that equation. X plus
What if you look at 1 plus 2y equals 14? Would that still be equal?
it's easy as well. You can tell me it's 10 and 14, but 5 and 9.
14.
Take away 5 on each side, x equals 4.
Oh, right, okay.
So if you had used A, you should get the same answer.
I know
Yeah.
why, sorry. 2 times 10.
So 2 times
14.
10, yeah.
14
And then
minus
14
10.
on the other. 14
Sorry, I
minus
put
10.
I put 5 in x's place, sorry.
Okay. So either or should work because when we check, remember when we check the answers, we check that it works on each. So this time, without having to draw the graphs and getting a paper and making sure my lines are straight, everything, I managed to get x and y. So the solution is x equal 4 and y equal 5. Now, we can quickly check that my answers is working. So remember the two functions, the two equation were x plus 2y equal 14 and x plus y. I'm going to put x equal 4 in x and 5 equal y. So 4 plus 2 times 5, that's 14. Good. And 4 plus 5 is 9. Then I know that my solution works for both. And that's the only solution that I can get from here. So this is called the substitution method. Sorry, the elimination method. And check in by substitution at the end. Okay. So that was the first example. Now try this example here. You need to decide what you're going to eliminate first. So remember earlier on we had x at the top and x at the bottom, yeah?
Yeah.
And we decided to eliminate x because they were the same value. Yeah, I've got 1x, 1x. I took them away. Just because you've got a minus in front, remember you've got the same value at the bottom, minus y.
Just get rid of them.
So minus y minus minus y is just minus y plus y, and they both got rid of each other. Taking away the same number makes it 0. Yeah?
Mm-hmm.
Because a minus minus, remember we said was a positive. So here, x minus x was 0. Minus y minus minus y is 0 too. Yeah? So that means I'm going to decide to eliminate first, or before you eliminate, yeah, label your two equations, A and B, decide what you want to eliminate. So we're going to eliminate y by subtracting b from A. So 2x minus x becomes x. The two y's are gone. 11 minus 4 becomes 7. So I've got my first point, or I've got my first of the two variable, x equals 7. Okay. And then the next stage, we said sub into one of the equations. So we're going to substitute x equals 7 into b, because b was just x minus 7 equal 4. So 7 minus y equal 4. So what do I need to take away from 7 to get 4? Y equal 7 minus 4, which is 3. Yeah, 7 minus 3 equal 4. Or you can say
-3. I don't know if I've done that right.
So what you could have tried the balancing method by saying, oh, I'm going to take away -7 on each side, right?
Done -7.
Then that means negative y equal -3. Negative y equal 3, you divide by -1 both sides.
Okay, so I had to go and follow there to get a pop to kind of.
So if you divide by, because you remember we said we've got an invisible 1 here, to get rid of it, you need to divide. And -3 divided by -1 is just y equal 3. So you could do it that way, or you can just decide, oh, you know, it's probably easier to deal with positives. I'm going to add y on each side and take away 4 on each side. And that means you don't need to deal with negative like we just did here.
Okay.
Because plus y, so you get 7 equal 4 plus y. Take away 4, 7 take away 4 is 3. Just that means 3 equal y, or y equal 3. Okay?
Okay.
But like I said, you will have more tendency to get someone making a mistake when he deals with negative than when he think about this and go, oh, you know what, it's probably easier if I make it positive. So the solution is x equals 7 and 3 for these two lines. And we check our answers by substituting them. So 14 minus 3 is 11. And 7 minus 3 is 4. So I know that my answer is correct. Okay. So now, for this third example, have you noticed this time we've got a negative y and a plus y? Negative y plus y, so as you can see, they've got opposite sign. So to eliminate them, after having decided which one is A, which one is B, to eliminate them, instead of taking them away, what happens if I add them up?
On either side? On.
Yeah, so if I add the top one, so remember, I'm going to decide to label them. What if I do A plus B? What's going to happen to the y?
Positive.
So if I do 2x plus x, what do you get? 2x add on, how many x? 2x plus 1x.
Oh, yeah.
3x. Now if I do minus y plus y, what do I get?
0.
0. So basically by adding them, instead of taking them away, I got rid of the y's. So you can eliminate by taking away if they've got the same sign, or you can eliminate by adding them if they've got opposite sign. So it's the choice that you make is based on the sign of your variable. So this time I'm going to add them up. And by adding them up, I end up with 3x equal 15. And you divide by 3 both sides, x equal 5. Yeah? So now that I've got my x, I'm going to substitute my x equal 5 into b, because it's the easiest one. 5 plus y equal 9. And that means y equal 9 take away 5, which is 4. So I've got my solution, x equal 5 and y equal 4. I'm going to check that it works. 10 minus 4 is 6. 5 plus 4 is 9. So we've got our 3 examples, and what you'll find out is by elimination is the way algebraically people will solve these kinds of work. Okay, so I've got your first homework that will just use those examples that we've done.
Thank you.
Oh, that's a homework too, actually. The first one was with the graphs, remember?
I will just
Yeah.
skip over.
Kept it quiet there, yeah?
Do that one after kissing.
And then you can decide which one you find easiest, but you'll definitely see that this method is much quicker. Okay. But the graph method is a method that is a good method to have, because if one day you can't remember this elimination technique, you can always use graphically, put your answer together. Because you know how to draw lines by just finding 2 points. Okay. So we're going to take a pause if you want, and then when we come back, we'll do one exercise together, just to give you an idea. Okay, and I'm going to pause the recording. Everyone can see the slide, yeah?
Yeah.
So in this instance, so what I'm going to try to do is I'm going to pick question E. Okay, so don't think it's the hardest one, because there are 4 or 5 more after E. So in order to do E by elimination, I'm just looking at, first of all, we're going to identify each equation. So I'm going to call this one A and this one B, for example. So I'm looking at X and Y, and this time what I can see is I've got negative 2y at the top and negative 2y at the bottom. They are both the same. So to get rid of them, because they're the same, I can just take away B from A. Okay, so in order to eliminate Y, I'm just going to do A minus B. And A minus B will give me X minus 3x, which is negative 2x,
Equals to 4.
equals 6 minus 2, which is 4. Okay, and what we've said before is, in order to solve an equation, because I've got time negative 2, if I divide by negative 2 both sides, by negative 2, I get x equal negative 4 over 2, which is negative 2. Remember that negative could be there at the top, it's the same. So 4 divided by negative 2 is just x equal negative 2. So I've got my first point. Now that I've got my first point, I'm gonna substitute x equal negative 2 into A or B. So I'm gonna pick A, for example. So if I substitute x equal minus 2 into A, so sub into A, we just call sub. Usually that's what people would write. Sub x equal negative 2 into A. Maybe what I should have asked Santa is to give me like a proper pen writer. Sub into A. Then that gives me negative 2 minus 2y equals 6. So this is the bit where I'm going to move 2y on the other side. That will become positive by adding plus 2y. And I'm going to move negatives. I'm going to move 6 on this side. That become negative 6. So negative 6, negative 2, that's negative 8 equal 2y. So basically 2y equal -8 should be my answer. And now I just divide by 2 both sides. That means y equal -4. Yeah. So I've got x and y for this pair of equations. So I'm going to quickly check that this solution works for both. So if I put -2 times -4, which is +8, so -2 plus 8 is 6. So I know that works for this one. And 3 times -2, that's -6, plus 8. So -6 plus 8 again is 2. So I know it works. So I know my solution here. If you want to write it as x and y coordinate, it's up to you. You don't have to. X equal -2 and y equal -4 is the solution to these simultaneous equations. Okay? So it's very much the same for all of these. You look at x and y. So this time we had to take them away. On the first one, you can add them up because they've got 2 different signs if you want to get rid of the y's. And whenever they've got the same sign, you just take them away. And you've got a few more to do on the other side. Okay?
Yeah.
So apply the same technique and you should be okay. So if we get the time later on, we can come back to some of these starter questions, but if one day you want to practice a wee bit, you can always do them. So this time we are learning to solve harder simultaneous equations, okay, when they've got 2 variables. So what do they mean by harder? Remember, it was easy enough when you had an x and a -x, or a y and a -y, or a 5y and a -5y, or when they had the same factor in front of them, it was quite easy to decide, oh, I'm going to eliminate them, yeah? But we can do the same here by finding, again, remember what we used to call those common denominators? So let's see if we can apply a similar technique with this. Okay, so basically what I want is to end up with a similar value of y at the top and at the bottom, or similar value of x at the top or the bottom. It's a bit like when we had 2 fractions. If I had a 2 and another fraction next to it with a 3, and we had to do a 2 times 3 to get 6, for example. Bless you.
Sorry.
So let's look at the technique. So first of all, the step 1 doesn't change. You need to decide which one is A, which one is B. Step 2, we're going to decide what we want to eliminate. Earlier on, the decision was quite quick because we could see that we had the same factors for each. But this time, let's say we want to eliminate y. Okay. In order to eliminate y, what I could do is, in order to get 3y there, yeah, so what you could do is you could say to yourself, if I time both sides of my equation, remember you can do the same thing on the left side of the equation or the right side, yeah? So if I time both sides by 3, what do I get? I get 6x plus 3y equal 27. I've just timed the left side of my equation by using the balancing method, this time timing instead of dividing, for example. But you need to time both as if you had brackets here, okay? And that's why you've got 3 times 2x, which is 6x, 3 times y, which is 3y. We're going to call this C, this new equation. And the B, we could have left it B, but because we're moving in letters, we're just going to call this D. And this time you're back to what you had when we first started. I've got 6x plus 3y, x minus 3y, I can just decide to do C plus D by adding them. So C plus D give me 6x plus x, that's 7x. The 3y minus 3y cancel each other. 27 plus 1 become 28. And now I've got x equal 28 divided by 7, which is 4. So I've managed to get x. To get y, you just sub x, again, the same technique, into one of the equation. We decided here to put it into A. 2 times 4 is 8. 8 plus y equal 9. I can see straight away that y is equal to 1. Or if you want by balancing, take away 8 on each side, y equal 1. Okay, so the only difficulty here was, it's not too difficult, is to apply the balancing method by making the factor of the one that you want to eliminate be both the same on each equation. Yeah?
Mm-hmm.
So the solution is x equal 4 and 1. Again, I'm going to check that my solution work. So if I put 2 times 4 plus 1, that's 8 plus 1, 9. 4 minus 3 times 1 is 4 minus 3 is 1. So I know this solution worked. Yeah?
Yeah.
So a second example, I've got 3x plus 2y equal 13. 2x plus y equal 8. Again, I can decide to eliminate y here by timing by 2 the second one, because I've got 2y at the top and I'll have 2y at the bottom. After obviously labeling my two equations, decide what you want to eliminate. So I need to time by 2 the second one. Remember, we time both 2x and y, so maybe it's a good habit to make sure that you've got your brackets, because if you time the second one by 2, you get 2 times 2x, which is 4x, 2 times 1, y, which is 2y. The bit that people sometimes forget to time is this. So probably it's safer to say I'm going to time by 2 this side and time by 2 this side, so that I know that I keep my balance of my equation. Common mistake, people forget to time the second one, or they only time the y and they forgot to time the x. So
yeah,
now,
it's worth actually.
yeah, when you start, I think before you get more used to it, it's probably worth putting the brackets and making sure that you show what you're doing by timing by 2. It's just minimizing the chance of making the mistakes.
You don't need to affect the top one there, it's just the bottom one. I'll eliminate.
So remember, we can pick A or B the same way. So you can, so it's just a pure choice. These don't have just one solution. They will get the same solution at the end, but what I mean is the step of working. We could have decided, instead of getting rid of the y, let's get rid of the x. The only problem here is you've got 3x at the top and a 2x at the bottom. This is where you need to find the common factor between them two, which is 6. So you need to time the top by 2 and the bottom by 3. And then you'll have your 6x at the top and the 6x at the bottom. But it's easier to just time by 2 than timing 2 of them. Again, less operations done, less chance to get it wrong. But you will end up with the same answer. So now that I've got C and D, I'm just going to take them away. Okay, remember, again, you can take away C. You can do C minus D, but you can do D minus C if you wanted to. Technically, if it was me, I would do D minus C, because 4x minus 3x is x. 16 minus 13 is 3. Whereas if you do C minus D, you'll get minus x equal minus 3. And then you divide by minus 1 both sides, and you will get your x equals 3. So it's up to you. So this time they've done C minus D by doing minus x equal minus 3, or x equals 3 by dividing both sides by -1. Okay? So once we've got our first variable out of the way, we just sub it into the B equation. Was the easiest. We had only y there, so 2 times 3 is 6. 6 add on 2 is 8, then y equal 2. So you've got your solution. Your solution is x equals 3, y equal 2. I'm going to check them. 3 times 3 is 9, 2 times 2 is 4, 9 plus 4 is 13, so that's good. 2 times 3 is 6, 6 plus 2 is 8. I know this is the correct answer. Okay. So we've tried a couple of examples. Now we're going to do a couple of practices, okay?
Not winding down for Christmas, are we? No.
But simultaneous equations, it's just more equations. But let's see here. How many have I got? Yeah, so I've got 3 on that side. Again, I'm going to try E. We're going to work on E together. So we need to decide what we want to eliminate. So looking at this, I've got my first equation, I'm going to call it A. My second one, I'm going to call it B. I've got A on its own. I'm thinking, you know what, it's probably easier to just time a number, you know, a letter that's got nothing in front. Just makes it easier for me. If I want to get rid of A, I need to time by 5A. Then that means I get 5A minus 15B. Yeah? Remember, we time the whole side on the left. Equal 5 times 5.
25.
And at the bottom, so we're going to call that C if you want. And at the bottom, I still get 5A because I'm not going to change it. Or you can say you've timed it by 1, B, plus 2B equal negative 9. Yeah, technically, if I call this D, it's a bit like I've done B times 1. Now I've got 2 new equations. To eliminate A, we're just going to do the difference between them two, yeah? 5A minus 5A gone, minus 15B minus 2B, that's minus 17B.
Is it not plus? Well,
So remember, we're taking away.
plus and minus, yeah.
Because I've got minus 15B minus 2B, now they've got the same sign. So it's the sign. Usually you put the sign of the biggest, which is minus, but because they've got the same sign, you add them. If they've got different sign, you take them away. But yeah, remember, technically we're doing that minus that, right? That's what we are doing.
C
Again,
minus.
at the start, maybe it's safer to just put the minus in the bracket so you know you're doing. And then the 25 take away negative 9 becomes a 25 plus 9, yeah?
Yep. 33.
So it's the same as 25.
34, sorry.
Yeah. So 34.
Is equal to 34.
Now we're going to divide by negative 7b both sides. Sorry, by negative 17 both sides to get b,
Negative 2.
which is, yeah, b equal negative 2. Now that I've got b, I need to sub b. I'm going to use into that a, capital A equation. So sub it into it. So sub b equal minus 2. That's why you put it into a circle. It's so easier to just... So that means I get a minus 3 times negative 2. So a negative times a negative will give me a positive, equal 5. Yeah. So that is the same as a plus 6 equal 5. So the only way you're going to make a 6 into a number less than 6 is by adding a negative to it. Yeah?
Yep.
So take away 6 on each side, and that means a equal 5 minus 6, which is just minus 1 or negative 1. So let's check that our answers work. So a equal negative 1, minus 1 minus 3 times minus 2 is minus 1 plus 6, which is 5, so that's okay. 5 times negative 1, which is negative 5, plus 2 times negative 2, which is negative 4. So negative 5 minus 4 is just negative 9. So these two, I've checked them, and they're okay. Yeah?
Yeah.
So the only difficulty here was making sure when you time by 5, you time the whole section there, both sides as well, and algebra, integers, you know, taking away a positive. And so I think that's the only difficulty here, is to manipulate all these negatives. Taking away a negative 9 becomes a plus 9. I can see that tripping a few. Okay. And then you've got a few examples. All right, so before we move into real life problem, I'm gonna let you have a go at these we starter questions if you want, and see how would you do fractions. It's just a bit of revision, really.